Welcome back. In the last section, we added multiple resources to our Terraform model, which could have either implicit or explicit dependencies on each other. In this next section, we're going to expand that model further again by adding a cloud backend. As you can see from the diagram, in these courses I'm planning to use an Amazon S3 bucket for this, but Terraform has several options you can use as a backend, and as you can imagine, it's common to just use the one that matches the cloud provider in which you're spinning up resources. So what is the backend used for? You might remember we previously discussed how when Terraform applies a set of changes into a cloud provider, it creates a file in the local storage called terraform.tfstate with a record of all the things it created. When a plan or apply is then run a second time, Terraform reads that file and then asks itself the question, what is the difference between tfstate and what I'm now trying to make? That difference is then expressed on the screen in the now familiar form to you, X to add, Y to change, Z to destroy, and then that delta list of changes is applied to the environment if an apply is run. In the case where a backend is configured, this process is exactly the same, except that now the TF state is stored in the backend after creation. So in our case, rather than being a TF state file on our local machine, that TF state file will now be stored in S3. There are two key reasons to do this. Firstly, it's pretty much mandatory for working in a team, as multiple team members will all need access to the same state file when working on Terraform. Having that state file in a central cloud location is vitally important to make sure you are all reading the same information. The second reason is that the TF state file is rather critical for making accurate changes to an infrastructure. If it is lost or damaged, then Terraform won't have any record of what you've spun up in the cloud and will try and make the same resources all over again, which would be a disaster in a large deployment. With that in mind, you don't want it stored somewhere unsafe, such as a laptop or desktop where it could be deleted. It wants to be in the cloud, backed up, and ideally versioned, which is an option on the S3 bucket. Okay, there are some other concepts we need to cover too, but first I think we should just go ahead and make a backend and have a little play with it. Let's open up a terminal again and browse to our Terraform repository. As always, you can find all the code for this and the other courses on Lernard free at the Lernard GitHub repo. At the moment, we're up to section 5, so let's create a copy to keep expanding our features called section 6. Great, there it is. Usually, we'll then use the command line to delete the .terraform folder and state files we've copied over that we don't need. But to maintain Lernard.com's position at the vanguard of excitement, I'm going to hop over into Visual Studio Code and delete them using the GUI this time. Also, now our codebase is growing a bit, let's start using the find and replace function here to rename any instances of section 5 to section 6 in the section 6 folder. If I press return once, it will show me a list of proposed changes. We can even click on one to get a nicely highlighted breakdown of what it will be changing. And as we're happy with that, I'm going to confidently click replace all here. Now we've finished cleaning our section 6 folder, let's create a new file called backends.tf. Just to mention again that you can call these files anything you want, and you don't have to split them up like this. You can just dump all the information in one file. But I've worked quite a few DevOps roles now, and the layouts I'm using here are the most commonly repeated patterns I've seen in my career. Good habits are as much a blessing as bad ones are a curse, so I recommend you always follow a neat and meaningful layout of file names like the ones we'll be doing in these courses. Right. Unlike most of the components we've been looking at, backends follow a bit of a different structure. They are defined in a Terraform block like this, which is where Terraform will look for general settings such as this, along with possible hard-coded minimum values for plugins and Terraform. You might reasonably ask why I've called the file backend.tf rather than settings.tf or something similar, and really it's just a matter of preference, but I've seen it most often named in this way. Inside the Terraform block, let's add a backend, and open another set of curly brackets for some options. First, we have to specify the bucket we're going to use because we'll be using AWS. This has to be created in advance, either using the AWS console, as we're going to do in this chapter, or using Terraform itself if you want to be super fancy. This might be one of the only occasions where I find it acceptable, even in industry, to do something manually, and I'll explain why in a moment. After the bucket, we have to choose a key for this backend. This is the equivalent of a path in a file system, but for a bucket. And finally, I'm going to specify the region. Right, as we discussed, I now want to manually create that bucket so it exists. So let's go to Firefox and open up the AWS Management Console. Browse to S3, and once it's loaded, click Create Bucket. Give the bucket the same name we chose in our Terraform code, remembering that all bucket names in the world have to be unique, so you'll need to have some kind of unique identifier, such as your name or a long string of random characters, or in my case, the word Lernard. From here on, we can just click Accept to all of the default options, as AWS chooses pretty sensible max security as the default. And now we can create our bucket. Now let's jump into the console and try using our golden commands, Terraform init, run, and plan, and of course destroy will come later. So, cd into the section 6 folder, Terraform init, there we go. Now a Terraform plan. This is saying 5 to add because we copied over the resources we wanted from the last section, where we had 2 instances, 2 IPs, and a bucket. That's fine with us, so let's apply that now. Great, it's done. If we now switch back to the web console and have a look in the backend bucket we created, you can see it's made a file called section 6 as we specified in the backend options. Let's download that now and take a look inside it with a text editor. If all this text looks strangely familiar to you, that's because it's the same as the text that was previously stored in the Terraform state file in our previous examples. As you were probably expecting, having said that's what was going to happen not 5 minutes ago, the state file is now being transferred into an S3 bucket, rather than being stored locally on the server. Let's quickly go and check a specific detail of something we've spun up to reference it against, such as an IP address of an EC2 instance. You can see here the address of 3.215.159.185, and we can confirm that matches in the Terraform state we now have in the bucket here. If we look back in the terminal and list out the contents of the section 6 directory, you'll also notice that the TF state files we would normally see after an apply are conspicuously missing. In fact, if we browse into the .terraform folder where we're downloading plugins, you can see there is now a .tf state file in there, but a quick glance shows us that it's actually specifying the location of the backend itself. You really don't need to remember any of that level of detail on a day-to-day basis, by the way. All you need to understand is roughly what a backend does and how to configure one by, in this case, creating a bucket in AWS, although for other providers the process will be slightly different. To demonstrate one quick final point, let's head back over to the terraform.tf var's values and change a couple of things, then reapply to make Terraform perform some changes. I'll change the number for count here to 3, and I'll change the instant type of the machine to a micro. Right, let's use Terraform apply to run this through again and wait for that to complete. I'll hop back into the web console now to confirm that's done. And now we can see it is, so let's go back to our state bucket again. Inside you can see there's still only one file. There's no tfstate.backup file like we had before on our local, there's still just the one remote file. One extra concept it's worth being aware of is called a state lock. As we mentioned earlier, one of the primary reasons you would want to use a remote state is because you are working as part of an enterprise team. The concept of state locking ensures that once one person begins to alter the Terraform state during an apply, the state is locked to anyone else altering it until after that apply is finished. If we consider a situation with two engineers trying to change an infrastructure using Terraform when locking is enabled, as soon as the first one kicks off an apply, access to write the state file is locked. If any other engineers do attempt to write that file by running an apply, they will receive a failure message telling them about that lock. While it's important to implement this in enterprise environments, the method for doing so varies depending on the back end. In our case, in AWS, we could implement this using a DynamoDB table. But as there's only one machine we're running things from, I don't think this is going to make for a very exciting demo. So it's just enough to be aware that this is likely to be set up wherever you go and work, and to know what state lock means if it ever warns you about it. So, as always, now we're done with our infrastructure, and we don't want to give any more money than we have to Jeff Bezos, so it's time to spin it all down with the Terraform destroy. And after that, let's wrap up this section by committing our code back into GitHub. So there we go, the destroy is done. Let's have a look here with the git status. Whoops, let me come up a directory so we can see what we've actually done. Git status, git add a, and now git commit with a sensible commit message, and then push back to master. Okay, we've made it to the end of another section. We're definitely starting to build up a more complete picture of how Terraform should be done in the enterprise. For the next thing, we're going to have a look at outputs and data. With only 2 sections left, we're almost there. Hopefully see you there.